Okay, it's great to be here. We just had our quarterly results, and so we released the number of employees, and it was only 13,000. But then I think I was here about 6 months ago. So if you were doubling, you'd expect 14,000 in half a year. So we're slowing down just a little bit. So Andre said it's great to go first because you don't repeat anything. It's almost as great to go second because there's less chance of repeating everything. And in one sense, my whole speech could be, I agree with what Andre said, any questions? But in another sense, to really show how broad this field is, I picked out a bunch of stuff and he picked out a bunch of stuff, and we'll see, I think there's not really that much overlap. So there really is a lot to say, even when you're just giving an overview. So the first thing I wanted to do was introduce this ice cream cone theory of information retrieval. And this is due to Amit Singhal, who's a Google fellow, and he should be here today. He knows more about search than I do, but he's back in Mountain View taking care of the present state of search rather than the future. So what does this mean? So if you look at the queries, and Andre covered this a little bit, so at the top of the ice cream cone, there's these queries that have lots of information on it. So, you search for Clinton, and there's 70 million pages that mention it. You search for Paris Hilton, and there's almost as many, unfortunately. That's the way the web goes. And then you start moving down the ice cream cone, and you get somewhere in the middle, and you search for Shankar Sastry, and for some reason, there's not as much information as there is on Paris Hilton. I don't quite understand why, but that's the case. And then you get more specialized, and you look for a topic that was on one of the courses he was teaching, Lipanov's theory of stabilization in C++, and it's pretty amazing that you still got 11,000 there. So the ice cream cone's getting smaller, but there's still a lot of stuff there. And then finally, you drop off the bottom. And so you say Lipanova nigritude minus ultramarine, and you get 0. And so there's a long history for that for those who aren't in the industry. Some search engine optimizers, which is the Web 2.0 term for spammers, got together and said, let's see who can get the best results on a search term. And we'll choose a search term that never appeared on the web before. So they chose nigritude ultramarine, and then they had a contest to see who could get the best results for that. So actually, if you look for Lipanov nigritude ultramarine, there are pages that have those 3 terms on them. So I had to put a minus sign in front of the ultramarine to get down to 0. So that's the theory of ice cream cones. And the idea is that you take very different approaches depending on where you are in the ice cream cone. And I guess one more thing to say is an ice cream cone wouldn't be complete without a consumer. So somebody's got to lick the cone, and we have to study not only the content that's over there in the cone, but we've also got to study the people who are trying to find that content and what they're doing, what they're looking for, how they interact, and so on. Okay, so let's look at some of the queries. So first, we're at the top of the cone. We're searching for Clinton. And the great thing here is that all the stuff you want to do with machine learning and statistics works out great because there's so much information. And you can pick any old dumb theory or algorithm, and they all work because, however bad your prior probabilities are, the data swamps the priors and gives you the right answer. So you can do lots of things. So you can do clustering, and you could say, well, here's the results for Bill, and here's the results for Hillary. And then I guess if you were asked, you'd have a little drop-down list with all the towns that are called Clinton in various states and so on. You could do extraction. You could figure out the dates that these people were in office and what their titles are and various other facts about them. You could think about novel kinds of presentation, maybe show all the events on a timeline or on a map. You could do integration across multiple sources of information. So we often think of only looking at the web as a source of information because there's so much there, but there's also other types of things like news and blogs and books and magazines and so on. Can we pull them all together? And if we can, how do we compare a news result to a web result to a book result, and where do we put them on the page and so on? We could do personalization. What do you or people like you want to see when they do this particular query? And then I think the type of user interface and having a mixed initiative is important. So not only is it the search engine giving you back an answer to the 1 or 2 or 3 words you typed in, but it's leading each other. Maybe you know a little bit more, and you can direct where you want the results to go. Maybe you're exploring, you don't know that much, and the results that come back should be leading you in the right direction. And so at the top of the cone, all these things are possible. Let's see. So here's just an example of doing extraction. So one of the things we do is try to pull out these types of information. So we know something about Bill Clinton as an entity. And when you ask a question like, who is Bill Clinton, we'll show you that entity. And when you ask other things like his title and age and so on, we'll show you facts about that entity. Here's an example of mixing and of mixed initiative. So we'll show you news results. We now actually, newer thing, we have news archive results. So we can say, what's the most important historical news about Clinton? Well, it's this 1998 impeachment process. And then also these related searches. Some of them include your original terms, Bill Clinton, impeachment photos, speeches, and so on. And some of them have different terms that are related, Monica Lewinsky and Jimmy Carter. Here's a completely different query. I cut off the top of the page, but this was the query Glacier Bay. And to me, it seemed like this was a navigational query, that there's this park up in Alaska. That's what Glacier Bay means to me. Why would anybody want anything else? When we started looking at the logs, we found lots of people were kind of searching down, and they wanted this Glacier Bay faucets. And I had never heard of that. I sort of thought, gee, if you want Glacier Bay faucets, you should type in Glacier Bay faucets. Because there's this other company that's actually a larger company, the number 2 result there, which says high efficiency cooling, heating, and climate control. And when people searched for that, they said Glacier Bay HVAC or something like that, and they got the right result. But for some reason, when they're searching for Glacier Bay faucets, they tended to leave off the faucet. And so we just say, well, I don't understand it, but the user's right, so we're going to give them this option to say, is this what you wanted? And you can only do that, I think no amount of thinking could have said, gee, Glacier Bay faucets is a good result for the query Glacier Bay. You just have to look at what your user's doing and trust them. Okay, so now moving down the ice cream cone a little bit, if we're looking for Shankar, you can try to do all the same things you did with Clinton. And as we said, you still got 200,000 pages or something like that. There's enough information there where you can do a lot of the same kinds of clustering and learning and so on. But then there's other things you want to be able to do. So you want to look at the scholarly material. Maybe you want to extract the social network of colleagues and co-authors and so on. There's an effect of varying document size. So if you're used to just looking at information in the chunk of the size of a web page, now all of a sudden you've got a 50-page PDF article or maybe a whole book. It's a very different process to search through those and do a search through that and show me what the best result is from a book or a long article as opposed to a web page. And you can start being more clever with your machine learning algorithms. So now this is the place where you have to put on your thinking cap. When you're at the top of the cone, just throw any algorithm at it, it's going to work. Now, as you get more specialized, you have to be a little bit more clever. So here's an example of the Scholar results, showing all the pages there. Now, as we move down, we get into these even more rare queries. Now what are we going to do? Well, so the query said C++, so now here's another genre that we have to deal with. For Shastri, we had the genre of academic publications. Now we have the genre of programs. When you start getting longer queries, chances are you're not going to get good results or you're missing results. So you have to think about query expansion, adding in synonyms for various of these terms. Maybe for stabilization, you want to add in stability, maybe terms that are even farther than that. And then also dropping terms to get more results. So maybe the word theory there isn't that important. I'd be happy to find a page that was about Lyapunov stabilization, even if it didn't have the word theory on it. But I have to know that it's okay to drop theory, but it's not okay to drop Lyapunov. So another a new piece we have is the code search. So you can type this in, and if you actually do the query just as it is, it turns out there's no results. But if you drop a few words, then there are a bunch of results there. I don't know if they're the right ones or not. We'll have to ask Sastry about that. And again, this is the type of thing that we would like to have done automatically. So I, as a user, it was up to me to drop those terms out and say, well, the first one I'm going to keep, the other ones I'm going to drop. We'd rather have more of a mixed initiative where you could say, maybe you should go in this direction. Okay. Now, a couple weeks ago, we were at this workshop. Barney was there with me. And one of the topics that came up was, gee, you know, what's going to happen in Cuba after Castro dies? How quickly is the culture going to open up? What kind of changes are there going to be? And we decided, well, one thing that'd be interesting to know to help predict that is what's the penetration of cell phones and the internet within the country to help see, you know, how quickly democracy can spread and so on. And so, you know, I sort of felt on the spot there, right? We were all sitting around this table, and here was this question of what's the right answer to this. And I'm the Google guy, so everybody looks at me and says, geez, how are we going to do that? And this is a hard kind of question, right? This is not the kind of question. I can't just type in, you know, what's going to happen in Cuba after Castro dies. It'd be great if we could type that and get an answer, but the state of the art in AI isn't quite there yet. And, you know, maybe I can type in a long sentence of what's the penetration of cell phones and internet and so on. But it seems like I had to choose some words. So I chose this, mobile phone usage, Cuba. And I did pretty well. So first, it seemed to read my mind, because the first page that came up had internet usage statistics right at the top. And that's something I wanted, but even though I didn't put it in the query, so that was just kind of an accident. And then you go down farther in the page, and it says, mobile rates are prohibitive for the vast majority of Cubans. So that gives me a pretty good answer, saying the answer is very low. But then I went back, and I did something that probably most of the users would not think of, is, you know, I use this strategy of saying, well, imagine the page I want to find. And I said, well, probably what I want to find is a page that has a big chart or a table. And the title of that should be something like mobile phone usage worldwide. So I made up that query. And the first result there actually gives me the answer. So there's Cuba at number 172. There's 200 and something countries in the world, so that's not very good. It's, and there's 75,000 phones there and so on. So I got the right answer, but, you know, I felt like I was doing a lot of the work. And we want to get to the point where I don't have to do that much work, where the initiative is more mixed. And then another approach you can just take is doing this more navigational rather than trying to get it all in one shot. So if I just type Cuba, then I know Wikipedia and the CIA fact book are pretty good sources. I'm more comfortable with the CIA fact book, especially for things like this where you want a lot of different statistics, because I know they have that. So I clicked on that one, and then I just used the browser to search forward for mobile, and in fact, it gives you an answer there. So a lot of good strategies, but if the user didn't know the strategy, they'd be lost. We got to be able to embody those strategies and help the user along. And in the future, what I really want to be able to do is I want to state this query, geez, show me some charts about cell phone usage in Cuba, and get an answer like this. So this is Gapminder, a new sort of statistical display tool that we're just starting to incorporate. Now, this is not actually the cell phone data. They didn't have that. This is just population data. But I'd like to be able to generate stuff like this on the fly just by making a request. Okay. And then finally, you know, what about that stuff that's way down at the bottom of the ice cream cone where there's nothing there? What can you do? Well, if you don't have it, can you do nothing? Well, one thing is to do better discovery of information. Say, what is the stuff I haven't found yet. Another is to just crawl more. So, spend more money for all those machines up in Oregon or wherever they are, and go out and find more pages. Select the right ones, or just, if you can afford it, select all of them. Look at alternate sources like books and magazines and so on, incorporate those. And another thing would be to synthesize the results. So, I don't even know what this query means, so it's hard to synthesize an answer for that. But if it's another kind of thing, like one of these table-like questions of show me the population of the top countries which satisfy X, Y, and Z, I may find that on 3 different tables in 3 pages. No one page gives me the results, but can I bring them all together to synthesize the result? So that's about all the strategies you have when you run out of pages that have anything on them. Okay, so in conclusion, it's a big job out there. Like Andre said, there's lots of exciting things to do, and we want all you guys to help us all do it. We want to improve the results one at a time or billions at a time, whichever works. At the top of the cone, simple statistics and machine language work well. As you push down, the models have to become more sophisticated. Interaction with the user is just as important. Systems building is also important because you got to build these things at scale to handle hundreds of billions of pages and users and so on. Finally, I want to say thank you, people. That means thank you, all in the audience, for listening, but it also means thanks all the people on the web who generated the content that's necessary to do this, and all the users who generated all this user data. All of them working together are part of this community that makes the whole thing work. Okay.
Thank you so much. Open for questions.
In your last set of, can you hear me? Okay.
Yeah.
In your last set of slides, you indicated that in the search, you look at some aspects of the context. Do you have any machine learning that's doing that, or how do you plan on doing that?
Yeah. So the answer is yes. We have lots of machine learning that looks at lots of things. I'm not sure which one in particular you were referring to. What's
Yeah, the search for mobile phones in Cuba.
Mobile phones in Cuba, yeah. So I'm not sure if there was context involved with that. That seemed more like this one here, particularly. Yeah. So that was just a map, stuff in the title and so on. Those are all good signs. We probably have a synonym that says mobile phone and cell phone are related to each other and so on. But I'm not sure how much context you really needed for that. But the answer is yes in general, that at every step of the way, there's so much data you can't do it by hand. So there's machine learning involved in ranking all the parameters and choosing the synonyms and everything else.
Hi, Steve Beck, visiting fellow, College of Engineering. Fascinating. Could you talk a little bit about searching images and pictures? And you've got some kind of user game set up to help develop tags.
Okay. Yeah, so historically we've done image search by throwing away the images and looking at the text that's really near it and just using that. Luis Manon at CMU had this game where 2 people don't know each other, log on at the same time, they're matched with each other, they're showing a picture, and if they both type the same word to describe that picture, then they get a point. And for some reason, people like this game a lot, play it for hours at a time. And so now these pictures are automatically labeled with identifiers. That seems like a good thing. He could only take it so far in terms of hosting it, so we offered to host it and hopefully bring in more users, and we're gathering that data. We've also started recently to actually start looking at the picture itself and trying to do some image analysis of the pixels. And you'll see more of that coming out over time.
Thank you. One more.
Thank you. Bruce Ulrich. You gave us a nice story about what was happening in Cuba. And if you wanted to make Google understand a little bit more, what would be the stages after the nice things, that the tricks, a trick used twice in mathematics is a method or something like that? And what are the steps, and how far along are you doing it how are you doing it in different parallel efforts to make the understanding?
Yeah,
what do you
so
think
there's,
the
so
next
there's
step
lots
is?
of different, excuse me, there's lots of different efforts. So, you know, what could they be? Well, one could be looking at follow-up queries that people do. So, you know, they do one query and they don't get the right answer, and then they come back and they do another query. We can learn from that because we have their query logs to say, when you start out at this query, you often end up at this one. So now, if somebody else comes and they have this exactly the same query, you can sort of mix in or suggest that they switch to this query. And then it's a harder question to say, if it's not an exact match, how do you generalize that? So that's one direction to go. Another direction to go would be better understanding of tables. So right now, we understand tables to the extent that, you know, the title of the table seems important and we know all the words in it, but we don't really know the structure of saying, you know, there's this kind of horizontal thing, and if you got a word here in the column and a word here in the row and they match up with a cell, then those three things are related closely to each other, even though they don't appear consecutively on the page. We really should understand things like that better. And then, so that would be a very simple kind of understanding that will allow you to do retrieval of tables better. The next level of understanding would be to, you know, sort of transform them into a database, and then you can do SQL queries where you're doing joins and sums and averages and so on. That would be a whole other level of understanding. And yeah, many other things as well. So we chip away at them one at a time and try to keep on improving.
So one last question, then actually I take that one.
It's your prerogative.
Yeah, I can abuse it. The microphone. What about actually breaking down the questions? So it means that before you start doing the search, just breaking down the questions, or just somehow doing interaction with the user, rather than just going in and just to understand that.
Yeah, so certainly we do that to a degree.
Okay.
You know, so when Bill Clinton's part of the query, we recognize that it's important that those things stick together, even though the user hasn't used the special syntax like quotes around it and so on. I remember doing an experiment back in '94, I think, when I was with Bill Wood's lab at Sun Microsystems, where we took a query and we showed you all the synonyms for each of the words in the query from WordNet and had checklists where you could decide which ones to add in and so on. And the result of that was, yeah, you got better results if you took the time to check off all the correct synonyms. On the other hand, if you just did 3 or 4 queries and interactions, you also got better results, and it took you less time than going through that process. So I think it's really a trade-off of when do we use the user's time versus when do we do things automatically in order to understand the query better.
So once more, thanks so much, Peter, for accepting our invitation.
Yeah.
So